So hi guys, my name is Professor Kofi, and we will be doing mathematics to this channel, and I would like you to subscribe so that we'll be together in this channel of mathematical knowledge. So we see different chapters like trigonometry, like conics, like space geometry, integrals, calculus, so everything in mathematics. So today we are going to start with trigonometry. So let's go. So chapter 1. Chapter 1, trigonometry. So 1.1 definition. Trigonometry is a technical term composed of two words, I think are Greek words, trigon and metric. So trigon trigonometry is a technical term composed of two Greek words. One is trigon, which means triangle. Other is metric, which means measurement. So you see that trigonometry may be measurement in triangle. So trigon is a measurement in triangle. So everything we will do in this chapter, it's about measurement in triangle. So I think this is the definition of trigonometry, where it comes, and let's start with trigonometric ratios. Trigonometric ratios are 6. There are sine, cosine, tan, and other three comes from that one. It means cosec, sec, and cotan. Trigonometric ratios are the sine, cosine, and tangent. So I can show you how there are on triangle. Let's use rectangular triangle to show what is sine, what is cosine, and what is tan. So here I can say angle alpha, A, B, C. So we know that triangle has 3 sides. The side where the angle cannot touch is called opposite side. Opposite side. The big one is hypotenuse. Other is adjacent side. Now, so what is sine of this angle? The sine of alpha
is equal to opposite over hypotenuse. It means AC over BA. Opposite over hypotenuse. The cosine of this angle is equal to adjacent over hypotenuse. It means BC over BA. The tan it is opposite over adjacent. It means AC over BC. And so we can rate the sine and cosine and tan. So what if I take sine over cos? Sine alpha over cosine alpha, it is AC over BA over BC over BA. So it is AC over BA times BA over BC. So once you simplify, you get AC over BC. So this one, it is this tan. So it means that tan, it is sine over cosine. So we'll be using this in future. So these are the trigonometric ratios, but there are others. Others are sec, cosec, and cotan. So what are they? No, hagarika tuye. So let's continue to see other trigonometric ratios. So our cosecant, secant, and cotangent. So cosec of this angle, it is 1 over sine of the angle. Sec, it is 1 over cos. Cot, it is 1 over tan. So if you can rate in terms of sine and cos, you see that cotant is 1 over tan. It is 1 over sine over cos, which is cos over sine. So these are trigonometric ratios. So there are angles which are known, like 30 angles, 30 degrees, 45 degrees, 60 degrees. These are very useful angles in trigonometry. So you can find sine of this, even cos and tan. The sine of 45, cos of 45, and tan 45. The sine of 60, cosine of 60, and the tan 60, like this. So the 30 degrees and the 60 degrees, you can take them from a equilateral triangle which has the side of 2 units. Okay. So I'll be sorry if I draw in a bad way. So 2 units, 2 units of length can be centimeter, meter, or what. It depends on what you want. So once I divide it into 2 parts, it means that this side, which was 2, it will be 1 at any place. Okay, because I take 2 divided by 2. So call it A, B, C, E. So this one is 8. Call it hash. 8. So each angle is 60 degrees because you know for a equilateral triangle all angles are equal. So once I divide the 60 by 2, I get 30 degrees. Even here there is 30 degrees. So I'm going to find the sine, cos, and tan of those angles. Now, let's begin by angle 30. What is sine of 30? Look at this. We have said that the sine is opposite over hypotenuse. So it is 1/2. Okay. Cosine 30. I'm here. So the cos is adjacent over hypotenuse. So the adjacent will be this h. So we are going to calculate h first of all. So we know that h squared, according to hypotenuse, it is 2 squared minus this 1 squared. It is 2 squared minus 1 squared. It is 4 minus 1, which is 3. So h will be √3 units. So the cos will be h/2. It means square root of 3/2. So the tan, I can say tan is sine over cos, as I have shown. It is 1. So it will be square root of 2/1. Sine over cos. It will be 1/2 over square root of 2/2. So it is 1/2 times 2/√3. Once you simplify, you get 1 over square root of 3 or square root of 2/3 if I rationalize. So this is tan of 30. So what is sec? Sec is 1/cos. So it is 1 over square root of 2/2, which is 2/√3. What is cosec? It is 1 over sine. So it will be 2. I remain with cotan. Cotan theory. It is 1 over tan. 1 over tan, it is this over this. So this is for angle 30. So let's go with angle 45. Angle 45. So before 45, let's look at 60 because I have it here. So angle 60 degrees. The sine of 60 is sine over cos. Let's take this. I mean opposite side over adjacent. So it will be h/2. It will be square root of 3/2. Cos, it will be adjacent over hypotenuse. Adjacent over hypotenuse. It is 1/2. And tan, it is sine over cos. Sine over cos. It will be square root of 3, of course. 2 over 1 over 2, which is square root of 3. So cosec, which is 1 over sine of 60, to be I think it is 2 over this, 2 over root 3, or 2 root 3 over 3. And sec, it is 1 over cos, to be 2 over 1, 2 over 1, which is 2. So cotan will be 1 over tan, 1 over tan, which will be 1 over this, which is square root of 3 over 3 once I rationalize. So this is for angle 60. So for angle 45, we use another triangle. You can use triangle of this case. It is a rectangular triangle. Whose one radius, 1 unit radius. So I need this h. H, according to Pythagoras, h is 1 plus 1, which is 2. So my h will be square root of 2 units. So this is square root of 2. So the angle here is 45, of course. So 45, then 90 to become 180 degrees. So let's look at cosine and tan of this. Take our guide. So let's continue to find the sine, cosine of 45. Angle 45. So the sine 45 is opposite over hypotenuse. It is 1 over root 2. So once I rationalize, it is 1 root 2, which is root 2 over 2. Cos, it is 1 over, because it is opposite over adjacent over hypotenuse. So also it is root 2 over 2. So the tan 45, it is sine over cos. It is root 2 over 2, which is 1. Okay. So cosec, it is 1 over sine, which is 2 over root 2. Sec, it is 1 over cos, which is 2 over root 2. Of course, it is square root of 2. And cotan, it is 1 over tan. So 1 over 1, it is 1. So these are very known angles. So I can give you a table which we'll be using, which summarizes this. So angle alpha, angle alpha, sorry, 60, 90, which I have not seen, but we see, and 180. Can take this. sine, cosine alpha tan. So you have seen that is a half. Cosine is square root of 3 over 2. The tan is square root of 3 over 3, as you have seen. Now, 60 sine, it is square root of 3 over 2, a half, and square root of 3. At 90, sine is what? So here we can use a circle of radius 1. One minus 1. This is sine, cosine of theta. So I can draw freely. Let's use this. So at 90 degrees, the journey begins here. Once you are here, you make 90 degrees. Okay. No, this is cosine. This is sine. Now, once you reach here at 90 degrees, you see that at sine you have 1. So on cos, you have 0. So the tan of 90 will not be possible because it is sine over cos. 1 over 0, it will be infinity. Okay, so at 180 you are here. This is 180 degrees. Yeah. Once you are here on cos, you have minus 1. On sine, you have 0. Okay. No. This is 0, this is minus 1. So the tan will be 0 over this, which is 0. So we can take this table in our mind. So next we are going to see the Pythagorean theorem on trigonometry. Sana mongono hawa na. So Pythagorean theorem. Of course, on trigonometry. So he said that cosine of angle, let's say theta, plus sine of the angle is equal to 1. Cosine square plus sine square is equal to 1 at any angle. So let's prove this. I can use, of course, a right angle triangle. Let's say we have hypotenuse 1, angle theta. So A, B, C. So, according to Pythagorean, we know that AC square plus BC square is equal to hypotenuse square. It means 1 square, which is 1. But remember, we have said that the sign of this, it is opposite over hypotenuse. It is AC over 1, which is AC. Cos, it is opposite over hypotenuse. It is BC over 1. So it is BC. So what if I take sine square? So the sine square, it is AC square. And also cosine square, it is BC square. So AC plus BC, replace them. AC it is sine square. BC of course is cosine square. So all of this it is 1. So this is where Pythagorean took the formula. I think it is clear. So from this formula we can have others like sine square per it is 1 minus cos. So it means that sine it is square root of 1 minus cos. Okay, this formula is very important. So also you can get another formula. Cosine it is 1 minus sine. So cos itself it is 1 minus sine then square root. This is very important also. So here I can give you an example how I can use this. Given that sine A it is 3 over 5. Cosine B it is like 6 over 10. No, 8 over 10, let's say. Or 4 over 5. So find tan A and tan B. So once I have sine A, to get tan A I need cos A. So we know that tan A is sine over cos. So let me find cos A. When you have sine you need cos, you can use this formula. So it will be 1 minus sine squared square root. So it is 1 minus this square square root. So 3 over 5 squared is 9 over 25. Can use common denominator 25. So 25 over 1 is 25 times 1 is 25 minus 9 then square root. 16 over 25. So square root of them is 4 over 5. Now tan A will be sine over cos, which is 3 over 5 over 4 over 5. It will be 3 over 4. Here. So to find tan B,